So the reason we use the quadratic formula is to solve equations that just look too dang hard. They're too complicated. We don't think we can factor them easily without a lot of mind-breaking hard work. So we're going to use the quadratic formula to make our lives a lot easier, right? When we look at this thing, it's not clear how we could turn it into factored form with two factors. We've got a 3x in there, we've got a 5. Maybe we can do it, but I have a hunch it's going to be a really big pain. So there's a tool we can use called the quadratic formula that's going to make our lives a lot easier. Quadratic formula is a little something like this. It says we can find the solutions to a quadratic equation, right? This is a quadratic equation. Its highest term has an x squared. By plugging some different parts of this into this equation. This is one you're just going to have to memorize. I'll post a little video for a song to help you memorize it. But this is what it looks like. It's a big fraction. We have minus b plus or minus the square root of b squared minus 4ac all over 2a. Now you might be thinking, what the heck are b? What is a? What is c? Where do I find these? It's actually not too bad. Let me use some different colors so we can highlight it. This right here, the coefficient of the quadratic term, this is a. So wherever we see an a, in this case, we're going to write a 3. Wherever we see, let me get a different color. Wherever we see a b, well, this coefficient of the linear term is b. So we're going to fill those ones in with 4s in this case. Last but not least, our constant, this is c. So wherever we see a c, we're just going to throw in that constant. So let's go to a new slide, to a fresh slide, and solve this one out. We're just going to plug all that stuff in, solve away. It might be messy, but we're going to do it. One more thing to note. When we use the quadratic formula, we're going to end up with two answers. And the reason for this is because we have this special sign right here, plus or minus. That means we're going to have one answer that is plus all of this stuff, and then we're going to do a second time and get a second answer that is negative b minus all this stuff in the under the square root. All right, so we have 3x squared plus 4x plus 5. And we're using the quadratic formula because we don't want to spend an hour trying to factor this thing. So here we go. We're going to plug it in. So we have negative b, right? B is 4. Let me relabel these just so we can have them nice and clear. So we got a, b, and c. So negative b plus or minus the square root of b squared minus 4 times a, which is 3, times c, which is 5, divided by 2 times a. All right, I'm going to simplify this out. We're going to multiply a bunch of stuff, start breaking it down. So we've got negative 4, that can't combine with anything yet, plus or minus 4 squared is 16, minus 4 times 3 is 12, and 12 times 5 is 60, divided by 6. Let's do one more step while we're here. So we got negative 4 plus or minus the square root of negative 44 divided by 6. All right, so here's where we're gonna break it into our two options. We have the first option, which is -4 plus square root of -44 divided by 6. And we have a second option that is -4 plus the square root of -44 divided by 6. Now, there's some properties of square roots that aren't going to allow us to actually solve this one because it's hard to take a square root of a negative number. You're going to learn more about that in Algebra 2. But these, if we were able to solve them, if we were able to reduce them down to a single number, would be the solutions to our equation. X would equal this, and X would equal this. Now, what I mean by X would equal these numbers is if we were looking at a graph of a parabola, a graph of the equation 3x squared plus 4x plus 5, and this isn't going to be the exactly correct graph, but let's say it looked something like this. Those two answers we got on the last slide, these two answers circled in yellow, those are going to be the places where our parabola intersects with the x-axis, right here and right here. Now, if you go to Desmos, you might find that I am just absolutely wrong, but it's the way we're thinking about it that matters. So we have, this would be the x coordinate of that point, and this probably would be the x coordinate of this point. The quadratic formula helped us solve for both of those x coordinates, for both of the places where our parabola goes through the x-axis. Now, we can actually use the quadratic formula for any quadratic, no matter how crazy it looks. So let's do one that we're really familiar with and see that it works. Let's say we have x squared minus 2x plus 1, right? Well, we know that this one actually factors down super easy into x minus 1 times x minus 1. You can use our rectangle diagrams to show that to yourself. But let's use the quadratic formula to prove to ourselves that it actually works this way as well. It can work on equations even as simple as this. So remember, we're going to be using A, B, and C. Here's my A. It's that secret 1, right? Our multiplicative identity. Anything that doesn't actually have a coefficient secretly has a hiding 1 as a coefficient. -2 is our B, and C is this last term. Let's plug it in. So we have -B plus or minus the square root of B squared minus 4 times A times C, all divided by 2A. Okay, let's look at this. So we've got, let's simplify it out. Negative times -2, or negative, this is like a -1 secretly. So -1 times -2 is +2, plus or minus the square root of -2 squared is 4, right? And negative times a negative is positive, minus 4 times 1 times 1 is just 4, divided by 2 times 1, which is just, which is just 1. So we're actually lucky in this case, right? 4 minus 4 is just 0, and the square root of 0 is 0, so that's just going to go away. So we're going to be left with the equation 2 plus or minus 0 divided by 0. Well, if I'm plus or minus 0, it's just going to stay the same, right? So we can just simplify this one even further. We have 2 over 2, which simplifies to 1. And when I looked at my factored form originally, I could tell that the only solution to this equation was going to be 1, right? If I plug in a 1 for this x right here, it's going to make the whole thing equal 0 because I'd have 1 minus 1, 0 times whatever the other factor is. And I also have a factor of, or a solution of 1 for this answer as well. And my quadratic equation gave me that. Sorry for the super jumbled slide, but as you can see right here, x equals 1 is the answer to our equation. We can see that in factored form, and our quadratic equation also gave it to us. So you might be wondering, well, if the quadratic equation can do that for super easy equations, should we use it? It's a good point. No, it's up to you to decide which style of answer will be more convenient for your quadratic. If it looks crazy, if it looks like it's going to take a long time to factor, don't waste your time. Just go to the quadratic formula. You'll have to do some math, but it'll work out faster in the end. It will get you the exact same answers as factored form. If you can see a clear solution to factoring equation, go ahead and factor it. That's totally up to you. Try it first by factoring if you're unsure. I think it's always good practice, and then go to the quadratic formula. It's up to you. You choose which one you want to do. They both work. They're both great. One helps us, this new way, the quadratic formula helps us cut through really complicated problems really fast.